Hello, fellow YouTubers. I hope you guys are okay, and thank you for joining me again. Today I'm touching on a very important topic. I'm doing a hyperbolic function, a hyperbola. Okay, a hyperbola, guys, is just a graph that has two restrictions. This graph is restricted both in the horizontal movement and the vertical movement as well. All right, together. So uh, the original graph of a hyperbola is a graph like this. Y is equal to a over x. Right, together. Please remember that a graph is just it's a joint line consisting of points, and each point consists of x and y. So whatever graph you have, it must its equation must consist of x and y. All together. Okay. Uh, for this graph, y is equal to a over x. You'll have two sets of different graphs. All together. If a is a positive number, you'll have a situation where a is also a negative number. All together. So if a is a positive number, it simply means that your graph you'll have y0 x-axis, y0 x-axis. Please don't forget to label your axes altogether. When your graph is like this, for example, say y is equal to 3 over x. 3 is a positive number altogether. This thing simply means that your graph will move from one restriction to the other on the first quadrant, one restriction to the other on the third quadrant as well altogether. In this case, whenever they say to you write down the equation of the asymptotes, you'll just say the horizontal asymptote is the line y equal to 0, which are the x-axis, and the vertical asymptote, it'll say x is equal to 0, which is the y-axis. Okay. An asymptote is a restriction that your graph should not touch. In this case, my graph should not touch the y-axis together. Hence, I'm saying the line x is equal to 0 is an asymptote, because x is only equal to 0 where on the y-axis, and another restriction is the x-axis. And on the x-axis, our graph should not touch that restriction. Together. Why? Because we have a horizontal restriction. Together. So I want you to note this: every horizontal restriction, or rather, every horizontal asymptote restricts vertical movement. Together. And every vertical asymptote restricts horizontal movement. Are we together, guys? Okay, but don't worry, we'll explain that further whenever we have these restrictions in the form of numbers. So whenever a is negative, for example, you have a graph of y is equal to negative 4 over x, your graph will be something that looks like this, from one asymptote to the other. So your graph will be on the second and fourth quadrant. Are you together? So same thing applies here. Your horizontal asymptote is the line y equal to 0. This is a horizontal asymptote. Let me highlight it in green. Horizontal asymptote is in green. And then the vertical asymptote, let me highlight it in red. Are you together? This is the vertical asymptote. Please remember, guys, always the time, the horizontal asymptote restricts vertical movement, and the vertical asymptote restricts horizontal movement. If you want to restrict horizontal movement, you must have a vertical asymptote. always the time. Are we together? Okay, and then in this case, the vertical asymptote is still the same thing. X is equal to 0. Are you together, guys? So if you have a graph like this, you are asked to draw a graph. There are steps of drawing a graph, ne? Okay, let me tell you the steps first. There are steps of drawing the graph. Firstly, you must write down your restrictions, namely asymptote. All together. Secondly, tell us the shape of your graph. By telling us the shape of your graph, you're just telling us where does it have to be. Are we together? Remember, it's simple. If A is a positive number like this, it simply means your graph will be on the first and third quadrant. So you'll just write therefore my graph is on the first and third quadrant. Right, together. And then if A is a negative number, therefore your graph should be on the second and fourth quadrant. Are you together? And then after writing down the asymptote, the other step is to finding the intercepts. The intercepts, for the intercept, number one, you have y-intercept, right? For y-intercept, I don't care whatever you're dealing with, just know that x is equal to 0. And then for the x-intercept, I don't care which graph you're dealing with, but always the time I know that y is equal to 0. Are you together, guys? Okay, and then and then after establishing your shape, writing your asymptotes, finding the intercept, you can therefore draw your graph. Are you together? Sometimes it happens that your graph does not have both x and y intercept. You must just indicate any point on the graph, and you must just have an extra point on the graph. Are you together? Example, let's say you have a graph of y. Please note this down, guys. They are very, very important. They are very, very important. Ne? Asymptotes, you must always have your horizontal asymptote and your vertical asymptote. Are you together? This is very, very important, guys. Write it down. Okay. Move. Let's say we have a graph of 2 over x. The first thing we must do, number one, the shape of our graph. How do we deal with it? The value of a is equal to 2, and 2 is a positive number. I can therefore conclude that my graph should be on the first and third quadrant. Are you together? Secondly, my asymptotes. Since I don't have anything added to x and I don't have any constant term here, it simply means that my vertical asymptote is a line where x is equal to 0, and my horizontal asymptote is a line where y is equal to 0. Simply means the x-intercepts, not x-intercept, rather the x-axis are my asymptotes. Y 0 x-axis. Are you together? And then thirdly, I know that my graph will never have the x and y intercepts because both the x-axis and the y-axis are the asymptotes. So I just have to indicate an extra point anywhere whenever I want to. My graph will look like this. Right, together, and then indicate just one extra point. You can choose any number. I can say that x is 1. Right, together. So I know that when x is 1, y should be 2. Wherever I see x, I must put 1. So it's 2 over 1 is equal to 2. So I know that my extra point, I have 1 and 2. Are we together? We do this so that you can be able to find the equation of the graph from just looking at the graph. Are we together, guys? So this is how you draw your hyperbolic function. So now the problem starts whenever we have restrictions. Let's start whenever we have a horizontal restriction. Let's say now we have a graph of y is equal to a x minus p. Are we together? Okay. For this guy is simple. We only have a horizontal restriction. Are we together? So it simply means that if we have an asymptote like this, we can have I mean, if you have a Cartesian plane like this, we can just have the asymptotes either this side or on the left hand side of the y-axis, depending on the value of p. Are we together? So it's simple. Let me just erase this. It's simple. Let's say if p is a positive number. Are you together? You will have two scenarios, guys. You will have two scenarios. You can have a situation whereby you have maybe 3 over x minus 2. Yeah, let's just draw this graph. And y is equal to 3 over x plus 2. I just wanted to show you how this asymptote will be placed. These two graphs are the same. The only difference is that you have a minus 2 at the bottom, and on the other side you have a plus. So your graph will just look like this. When at the bottom you have a minus 2, I need guys, you know that for our whenever we're dealing with fractions, the denominators should not be equal to 0. So we can just say x minus 2 cannot be 0, and that's our restriction, by the way, which is x is not equal to a positive 2, because when you take it to the other side, the sign will change. So your asymptote will be here when x is a positive 2. Are you together? This is how your graph should look, and it will be simple to draw it. You will all see it will just move like this and this. Are you together? And then whenever you have an asymptote like that, it simply means that x plus 2 cannot be equal to 0. Therefore x cannot be equal to a negative 2. That means your asymptote is on the left hand side. Are you together? And then your graph will look like this and this. Are you together? Okay. I don't want you to cram it, guys, né? But if you have a numerical value here and the sign here is minus, it simply means your asymptote is on the right hand side of the y-axis. And if you have a numerical value there and here you have a plus, simply means your asymptote is on the left hand side of the y-axis. All right, together, let's do some examples. Please note the steps still apply. Now let's draw a graph together. Y is equal to 2 over x minus 3. Okay, number 1, the shape of my graph. For me to find the shape of my graph, I must look at the sign of A. A is 3, and 3 is a positive number. Therefore, I know that my graph will be on the first and third quadrant of my asymptotes. Are we together? And then step number 2, write down the asymptotes. Write down the asymptotes. Ne? For my horizontal asymptote, there's nothing that is restricting my graph horizontally. So y will be equal to 0. Are you together? But for my vertical asymptote, I know that x, when x is equal to 3, my graph does not exist, because when x is 3, this entire thing will be undefined. Are you together? And then number 3, for x and y intercepts. For x intercepts, I don't care what kind of a graph we are dealing with, but always make y to be 0, solve x. Are you together? In this case, we won't have x-intercept. Why? Because the line y is equal to 0 is our restriction, but we can't do so. We can try to do it. Say 0 is equal to 3. Is it 3? And 0 is equal to 2 over x minus 3. Multiply both sides by x minus 3. You'll have 0 is equal to 2, which is not true. Right, together. So we don't have x-intercepts. Why? Because the x-axis are our restriction. This guy represents the x-axis. Remember that the line y is equal to 0 is always the x-axis. And then we must find the y-intercept. For the y-intercept, I don't care what kind of a graph you're dealing with, but x is always equal to 0. Go to your equation, make x to be equal to 0, then solve for y. Y is equal to 2 over, just put a 0 there, that means y will be equal to negative 2 over 3. So now I have my intercept, my restriction, and I know where my graph should be placed. Okay, we have y 0, x-axis. The only intercept that we have is x is equal to 3, which is here. Didn't no. Excuse me guys about that, but the only intercept that we will have, the only asymptote rather, will be here when x is equal to 3. Are you together? So I know that my graph will move like this from one asymptote to the other. The other one will move like this from one asymptote to the other, and it makes sense because my y-intercept was a negative number. It's a negative 2 over 3. Please pause the video and try to do this one on your own, then come back and join us, and then we'll do it together. Y is equal to negative 2 over x plus 3. Okay, number 1, your asymptotes. Your asymptote for your vertical asymptote simply means x is equal to a negative 3. I said if it's a plus, this thing will be on the left hand side. So negative 3 is here. So that's where you'll find your asymptote. Like this, né? And then for horizontal asymptote, in this case y is 0. Are we together? The x-axis, are your asymptotes. And then secondly, you must establish the shape. Are we together? A is equal to -2, which is a negative number. So we can therefore conclude that our graph will be on the second and fourth quadrant. Are we together? Then thirdly, for the x-intercept, just make y 0. Our graph does not pass the line where y is 0, so therefore there are no x-intercepts. Are together? Then for y-intercept, just make x 0 and then substitute for y-intercept. Make x 0, solve for y. Y is equal to -2 over x plus 3. Is it x plus 3? Yes. Okay, just go there and then put 0 whenever I see x. Therefore y is equal to -2 over 3. Okay, so I know that my graph will be here and here. This guy will be -2 over 3. Are we together, guys? So this is how we move whenever we only have a vertical asymptote. And as we can all see that for a vertical asymptote, since you know that our vertical asymptote is a numerical term, we can see that this vertical line here restricts the horizontal movement. Are we together? It pushes our graph further up and pushes our graph further down. Are we together? Such that our graph should not touch the line of x is equal to a -3. Now let's deal with a horizontal asymptote, and then we'll later combine it. Y is equal to a over x plus q. Are you together? This thing is simple. If q is positive and if q is a negative number, when q is positive, it simply means that your asymptote is above the x-axis, like this. But if q is negative, it simply means your asymptote is below the x-axis. It's as simple as that, guys. Are you together? So let's do one example. Y is equal to 2 over x plus 4. Okay. Please note, if we only have one restriction shown, like for example here we only have a horizontal asymptote, but there's nothing added or subtracted to x, it simply means there will not be an x-intercept. No, man. The x-intercept will be there, but the y-intercept won't be there. Excuse me. For the previous one, we didn't have the x-intercept. I just made a mistake there. Okay. Let's just draw the steps. Find the asymptote. Find the asymptote. I know that for my asymptote, the line x is equal to 0 is my asymptote. Hence, we will not have y-intercept. And another one, y is equal to 4. For y, we just take it as it is. If it's a positive 4, that means the horizontal asymptote will be equal to y is equal to 4. Right, together. And then number 1, number 2, the shape of our graph. A is equal to a positive 2. 2 is a number which is greater than 0. Simply means that my graph will be on the first and second quadrant. Right, together. Number 3, since I know that I wouldn't have the y-intercept, I can just go and solve for my x-intercept. Right, together. For my x-intercept, always the time, make y 0, solve x. So I know that I have y is equal to 2 over x plus 4. Right, together. If I make y 0, simply means I'll have 2 over x plus 4. Then I'll take 4 to the other side, it will be negative. I'll have 2 over x. Then I'll have 4x, multiply both sides by x. And then x is equal to negative 2 over 4, which is negative 1 over 2. So this is my x-intercept. So whenever I draw my graph, remember guys, I have my asymptote. Ne? Here is it. When y is equal to 4, I have together, and that's my only asymptote. And my graph is on the first and third quadrant. Excuse me, first and third quadrant, because this guy is positive. Right, together. So my graph should look like this. Excuse me. This will be my x-intercept when x is equal to a negative half. Always label your x's y, 0, x-axis. This is how my graph should look like. Okay, and then please pause the video and do this one on your own. Negative 1 over x plus 2. Okay, the first thing that we do, must find the shape. Ne? A is a number which is equal to negative 1. Negative 1 is a number which is less than 0. Right, together. So therefore my graph will be on the second and fourth quadrant. Right, together. Number 2, the asymptotes. I know that y will be equal to 2. Okay, let me just write it like this. For my horizontal asymptote, y is equal to 2, and my vertical asymptote, x is equal to 0. Hence, we will not have the y-intercept in this graph. And then finding the x-intercepts, I don't care, make y 0. Doesn't matter what kind of a graph it is. Y is equal to negative 1 over x plus 2. If y is 0, just need to solve x. You'll have a negative 2 is equal to negative 1 over x. Multiply both sides by x. You'll have negative 2x is equal to negative 1. Then x is a positive half. This is the only intercept you have. So what you have to do is to just draw this graph. Y 0, x-axis. The asymptote is there. Okay, and then all I need to do is to just draw the graph. I know that my graph will be on the second and third and fourth quadrant, so it will go like this, and it will go like this. This guy here is a positive half. as you just found out there. So that's how you draw your graph whenever you have one asymptote. I'm assuming that for the grade 11 part, for grade 10 rather, we are done because they did it one asymptote at a time. But grade 11 and 12, it's always two asymptotes. We have y is equal to a x minus p plus q all together. This graph is very simple, guys. The thing that you must know is that your horizontal asymptote always the time x is equal to p, your vertical asymptote always the time y is equal to q, and then they'll ask you about the domain of your graph. The domain of your graph. All you need to do, you can just say x is an element of real numbers, but x must not be equal to p. Right, together. And then for your range, simply say y is an element of real numbers, but y must not be equal to q. Are you together? So let's draw our graph. Y is equal to 2 over x minus 1 plus 3. Okay, but to draw the graph, we are given this. The first thing you need to do, and what I like about the question paper is that they will ask you these things bit by bit. Maybe the first question will be like, write down the equation of the asymptotes. Then you write them down. Second question, calculate the x-intercept. You do so. Then calculate the y-intercept. Then you draw the graph. It's as simple as that. Okay, let's draw our graph. Step number one, our asymptotes. For the asymptotes, always for the horizontal asymptote, for the horizontal asymptote, y is equal to 3. And then for our vertical asymptote, x is equal to 1. Are we together? And then number 2, shape of the graph. A is equal to 2, and 2 is a number which is greater than 0. So therefore my graph will be on the first and third quadrant of my asymptotes. Then number 3, I can just find my x-intercept. My x-intercept, I don't care what kind of a graph I'm dealing with, I just need to make y is equal to 0, solve for x. I have 2 over x minus 1 plus 3. Just make y to be equal to 0, solve x. Take the 3 to the other side, you'll have a negative 3 is equal to 2 over x minus 1. Right together, then we'll have negative 3x plus 3 is equal to 2. Negative 3x is equal to a minus 1, because when you take this to the other side you'll get a minus 1. Then x is positive 1 over 3. Right together. But just after finding the asymptotes, I just need to draw them so that I would never forget. I know that x is equal to 1. Let me draw them in orange. X is equal to 1 and y is equal to 3. Right together. So since my graphs will be on the first and second, okay, let me just continue. Stop clamalazing. This is 3 and this is 1. Okay, and then number 4, I just need to find my y-intercept. I don't care what kind of a graph it is, I'll just make x 0 and then solve. Y is equal to 2 over, I'll just make x 0 and then solve. This was my equation, right? Yeah, 2 over x minus 1. Okay, here I'll have a negative 2 plus 3, which is 1. So I know that my y-intercept will be at y is equal to 1. So my graph will move like this. On the first quadrant of the asymptotes, it will move here, and then it will move here. It will cut at 1, and here it will cut at, what did I find? 1 over 3. This is how you draw your hyperbola, guys. Please pause the video. Oh, and then they'll ask you to find the domain. Domain, guys, you just need to scan your graph horizontal. Where is your graph restricted? My graph is restricted here. Remember, I said to you that the vertical asymptote will always restrict the horizontal movement. So my domain, I know that my graph is real everywhere. But the problem comes when x is equal to 1. Now, are we together? So my graph is real everywhere, but x cannot be equal to 1. Are we together? Other people prefer it to write it like this. X is an element of negative infinity until 1, or 1 to positive infinity. It's up to you. But these two things are the same. Others would prefer to write it like x is between minus infinity and 1, or x is between 1 and positive infinity. This and this and this are the same thing. It's up to you how you put it. Are you together? And then the range. And then the range of your graph, you just scan your graph vertically. Whenever you move from top to bottom, or from bottom to the top, where is your graph restricted? I can see that whenever I move, my graph is real everywhere, but the problem comes when y is equal to 3. So I know that for my range, y is an element of real numbers, but y cannot be equal to 3. Are you together? Others can prefer to write it as y is an element of negative infinity to 3, or 3 to positive infinity. Others will just say y is between negative infinity and 3, or y let me write, or y is between 3 and infinity. Guys, this guy, and this guy, they say the same thing. It's up to you how you prefer to write it. Are you together? And then we will have draw this graph on your own, and then you will come back, we'll check it together. ngathi ngaphuma nga ithi zukuzukuzu ngathi ngagibida. Okay, let's go, guys. Number 1, what is my shape? A is equal to -2, right? -2 is a number which is less than 0. Simply means that my graph will be on the second and fourth quadrant. Are we together? Okay. Then secondly, my asymptotes. Hey, my learners once corrected me that asymptote has one S. Let me do so. Let's go YouTube. Okay, for the asymptote, I know that for my horizontal asymptote, I only need to write y is equal to 1. My vertical asymptote x is equal to a -4, and then whenever I need to find the x-intercept, all I need to do is to make y to be equal to 0, and then solve. When y is equal to 0, I just need to say what's the equation? It's -2 over x plus 4 plus 1, and then this guy is 0. I need to solve x. The 1 will come this side. I'll have a -2 over x plus 4. Multiply both sides by x plus 4. I'll have a -x minus 4 is equal to -2. -x is equal to a +2. Then x is a -2. Now together, and then for my y intercept, I just need to make my x to be equal to 0. Right, together, so I'll have y is equal to -2. All I need to do is to make x 0, then solve for y. Therefore y will be equal to -1 over 2 plus 1. I'll have 1 over 2. Okay, and then I'll just need to draw my graph here. I know that for my asymptote, let me write them in orange. I have 1 and I have -4 here. Please remember that whenever this guy is positive, your asymptote will be on the left hand side of the y-axis. -4 and 1. Okay, my a is negative, so my graph will be on the second and fourth quadrant, right? So my graph will be here, and then the other one will be here. I know that this guy is 1 over 2. This one is a -2. So guys, this is how you deal with hyperbolic functions. Please stay tuned, wait for more videos, subscribe, recommend to others, share. Yeah, thank you for watching.